Hello and welcome to Start Learning Numbers, a video course where we will discuss all the different sets of numbers, starting with the natural numbers and going all the way until we reach the complex numbers. But first, I want to thank all the nice people that made this course possible by supporting me on Steady and PayPal. When you first see mathematics, you often see that mathematics starts with calculations with numbers. And the numbers start with the natural numbers. They are called natural numbers because they are an abstraction we can immediately see in our natural world. In fact, even as children, we already get the conception for counting things. And the abstraction or generalization that comes from counting different objects is what leads us to the natural numbers. So they just represent different sizes we can have for collections of some objects. Therefore, it makes sense to introduce new symbols for these representations. Now, please keep in mind, for the mathematics we will explore, it does not matter which name we give these numbers, but the actual concept of numbers is important. With this, you could say the natural numbers we want to consider is the set n that consists of all of these new symbols. However, if you watched my explanations for the set theory, you already know that this here is not a complete definition for a set. Therefore, the question would be, how do we define the natural numbers just with sets? This is what we'll answer in this video. More precisely, we will construct the natural numbers that also include 0 as a number. I will use the symbol n0 for this set, but be careful, often also n is used for this set here. Okay, with this, let's start constructing the natural numbers. As we have seen in our examples with apples and oranges, the size of a set can be used to define a number. And we already know one particular set, namely the empty set. By definition, the empty set does not have any elements, so it represents the number 0. And now it makes sense to use this as a definition for our new symbol 0. Maybe it looks a little bit strange here, but keep in mind, we already have the set theory, so it makes sense that every new object we introduce should also be a set. We did the same thing when we introduced ordered pairs and maps. Now for the next step, for defining the number 1 as a set, we need a new set that contains only one element. We could take any element we want, but the only thing that is defined yet is the empty set. So we put 0 inside the set brackets and we get out a new set. What you should see is that what we do here is exactly the same thing we had in mind when we dealt with the oranges. However, here we don't need any real-world objects, we just need the abstract concepts in set theory. Okay, now for the number 2, we need 2 elements, so what do? We take the only 2 elements we know. So 0 and 1, because we know they are different. At this point you should see how this game works, and we can just continue it. Therefore, this is our number 3 as a set. In the same way, we can write down the number 4. However, here you might already wish for a shorter way to write it down. And of course, if you compare to the set before, 3, we just add one element. For this reason, we can just write it as a union. So this is what it is, and maybe it looks again a little bit strange. But keep in mind, 3 is a set here, and here we have the set that contains 3 as an element. Okay, but with this formula you now know how to construct the next number in order. And then we get all the numbers we want to have. And after that we want to put them into one set and call it the natural numbers n0. However, there you might see a problem because this whole construction here never stops. Or to put it in other words, the natural numbers, the set n0, should have infinitely many elements. And that is something we have to put into our set theory, so we call it an axiom. It's simply something we put as a true statement into our theory. For example, the existence of the empty set was also an axiom we put into the set theory. And now we want to put in the existence of the natural numbers. So we say there is a set n0 with the following 2 properties. The first one is that we have a starting point at 0, so the set 0 lies in n0. And the second one tells us that for all numbers in n0, Also the successor lies in n0. And now we know we can write it as this set here. As a reminder, here we have the conditional from logic, and I already told you, sometimes it's written with a doubled arrow. Later we will also do this just to avoid confusion with the arrow from maps. However, to finish our axiom here, we also have to say that n0 is the smallest set that has these properties. This simply means that any other set with these two properties is a superset of n0. Okay, and with this, we finally have the natural numbers in our set theory. It's constructed with sets, it has sets as elements, such that we can work with it. That's how you should see it. It's not the explanation of numbers, it's a working tool for us. Therefore, it's often called a model for the natural numbers. Now, with the natural numbers, we immediately get a map we call the successor map. We denote it with S and it goes from n0 into n0. And the definition we already know, we send the number x to the union. Because we learned, this gives us the successor. For example, if we put the number 6 into the map, we get out the number 7. Okay, I think that's good enough for an introduction. In the next video, we will talk about all the properties of the natural numbers and also how we can define the addition. So I hope I see you there and have a nice day. Bye!